Hello. So I had an idea. Because we are in a d-dimensional vector space and features are probably many more than the number of user types, so we can assume that like we can find easily we can find m types or orthogonal vectors, and then the only thing we need is just to make the sigmoid in a way that when the inner when the inner product is 0, we want the related relevance to be very low, and when the inner product is 1, it's quite high. What about when the relevance is negative? Inner product is negative. So that's the thing. Maybe we can use cosine. Or we can just, absolute value of the inner product, because what does a negative inner product even mean? So I think we can talk to ChatGPT about that part. Like, it's just a matter of design. Given d is far bigger than m, it is easy to pick m orthogonal directions. M orthogonal direction, and as centroid of types for a centroid of types, and the only thing is that when the inner product of type and the feature vectors are close to 0, relevance must be small, and whenever they are in same direction, relevance should be high. Also, what about big, large negative inner products? Define it as higher limits. Yeah, I make this up. Product relevance score. Item J. So we have a standard convention. Okay, negative inner product means low relevance. Yeah, I don't like that. So that's a good option. 1 minus e to the minus alpha I transpose xj inner product to the power of 2. So when they are orthogonal, we will have 0. And when they are big, we will have higher power. Cosine, well, we don't. So let's choose choosing sigma, small sigmoid that is low for 0 and all negative numbers. But it is the same stupid function. Okay, that's good actually. Alright, I like that sigma. It's just the shifted and scaled version of the previous one. So we don't need to change the code a lot. Okay, if we are on d minus 1 unit sphere and want to choose, yeah, I think choosing orthogonal is not the best. If we are on d minus 1 dimensional unit sphere and want to choose m points on it so that they are as far apart as possible from each other, what is the best choice? So let's do it. This is a nice geometry. So if you're on an and, by the way, assuming m is much less than d, so if we are on a sphere and we want 1 point, there is no 2 points or the 2 end of it. 3 points. What about 3 points? I mean, we have so much space, I think. Euclidean, by the way. So we are on this, and I wanna pick 3 points. I'll just choose. What does that mean, by the way? Is it like sigma of the distances, d of xi, xj, I and j, I not equal to j? Maximize. So if we are on a unit sphere, why should I not choose like one of the big circles and go, for example, 120 degrees on each side? Why not these 3 points? Does being on the third dimension add any value? So let me open this in a new chat, because it can ruin the whole thread. first of all, every 3 points will be on one plane. So in that plane, they're on the same plane, so it better be on the biggest plane, like the biggest circle. So I think for 3 points, yes, we are correct. But what if you have 4 points and we want them to be as far as possible? 4 point is just more, m is greater than d, but still interesting. What if it is the prism? Huh? Yeah, that's like a chemistry molecule. What is it? CH4. I think that should be that. Let's repeat the vertices of a regular n-1 simplex. Alright, on the sphere. Yeah, sounds like. So if you are going inner product, oh, okay, their inner product, if they are the same, will be 1, and if they are not the same, will be -1 over m minus 1. What if m is greater than d? What stops us? I think we should do the same. M simplex, but what if m is greater than dimension of space here, like m4? What if it's like 5 points? 5 points, now I don't have any idea of that. Simplex. But it's not our case, to be honest. The picture is going to 2 regime. M is greater than d plus 1 and less than 2d. Use a subset of the cross polytope optimal. Okay, you take the plus minus 1 E1 plus minus ED on SDI. Any two non-antipodal points are orthogonal, so the minimum pairwise distance is square root of 2, right? So you can't do better than 90 degrees separation in this range, so this configuration. Okay, if m is greater than 2d, no universal closed form optimum, use spherical code ETF if they exist. And the best possible minimum distance must drop below equiangular tight frame. So they should be equiangular. Alright, that's nice. when one exists for your EM ETF sample, you want to have kind of symmetry. Welch bound, wow, these are all studied. So if M is less than or equal to D plus 1, we choose the simplex, regular simplex. M greater than D plus 1, less than or equal to D, all the main directions. And M greater than 2D, aim for ETF, otherwise use high equality. How do you attack this guy? I like to know. Spherical code problem in coding theory geometry. Thames problem when the inertia was for pollen grains. Discrete geometry, metric geometry, combinatorial optimization, coding theory, harmonic analysis, frame theory. Okay, good. So, okay, we don't want to get super deep right now because it may not be our main question. This is an invention project. It is not a optimization theoretical problem. So I suggest that we just want to make them orthogonal. Okay. Let's them make this small change. I don't want to implement the simplex thing unnecessary, too much. Rustling. Rustling. And yes, let's get done with featureization, and we wanna also add randomization. That's nice to have. Um, I think we are spending too much time on this. It is interesting. I mean, I think at the end we will go all this direction, merge all of them together, but right now I don't think it's necessary. Still hurts. I think I should buy the mine's time 8. What was the other one? I want to know. Hmm. Uh, I- size is massive. Okay, so we just want to change the sigmoid function. And then I want to also choose the base in a controlled way. So it's just right now it's just random normal M and D. And what is D, by the way? D is like 5. And yeah, D is greater than M for sure. So right now I generate the center randomly. Let's make them orthogonal to each other. Also, the one that gives me simplex what was that? Okay, it's fast. So what size should I buy? Size. Wait a second. A pair is 29. Single is 21. Why should somebody buy that? So what size should I buy? Well, there is no help for the size guide, alright. Bicep circumference. How should I know? Okay. Oh, okay. So we wanted to set the base and orthogonal or simplex and ding ding ding. Option 1, orthogonal vectors. Two ways to generate your M-based centroid vectors, A1 to AM. They are maximally separated, either orthogonal or forming a regular simplex. We want to share these centroids between intents and features. For LM, here is clean code for both methods with explanation. Oof. Here's clean code for both methods with explanation and comments for switching between them. Orthogonal vectors, we have this function, generate orthogonal centroids, generally with M, orthogonal unit vectors in D dimension, D is greater than M, D greater than or equal M, and Q underline equals lean algorithm dot qr np. Oh, so wait a second, what is this super cool function? So with random matrix and apply Gramish. Oh, I see. So leanalg.qr, what it does is first you generate a random matrix and then it starts it does Gram-Schmidt on it and creates a orthogonal matrix, a base, and 1 1 to m. What does that mean? The t. Okay, so then we take the first rows, m times d, return a base. Alright. So because it starts from d times d matrix. Alright. Then we have regular. What if this is very high? Simplex and unit sphere using Rm minus 1 that are maximally spread. Then pads. So first gives us m unit vectors in Rm minus 1 and then pads them to Rd. Fucked up my elbow in wrestling yesterday. M points in Rm minus 1, therefore that form a regular simplex NPIm minus 1 over m. Centered simplex in Rm, so it's the formula for them. USVT, then we have like some function. What does this do though? Oh, okay, just the function that does all the thing, padding them. I just simple. And what else, guys? What else do we want? Is feels good. I have headache. If your head aches, I would rather beat it yourself, right? So you I think that makes sense. Why should let the pain gives you ache while you can't do it yourself? Try. Colonel died. So let me add this to the code. let's also get to know the code about simplex. That function is just Gram-Schmidt, so I think that is fine. And for the simplex one, oh, okay, QR decomposition of them. So we want the orthogonal matrix. Okay, it really hurts. I think I lost some ligaments or tendon here. Doesn't hurt all the time, but hurts right now. When I do this, it hurts. Pushing hurts. Pushing hurts too. Pulling also, my wrist hurts. So let's run this and let's see. Dude, my head is freaking hurts. Oh! Why n is len of item cluster? So 1 to m, but we have a alright, so item cluster, to each item assigns its cluster. N is len of item cluster, yes. Let's have 2 dimension, 2 user types, 5 dimension, and 10 items. And see how it goes. And then we go compute through our matrix and through our estimated. So we have true and estimated values printed. Estimated user type distribution, one is 0.8. Why did I choose it randomly? It's not a good choice. Where do I choose them? Yeah, let's just keep this one. Commented out, and we can keep the Q. I don't mind. I mean, fuck that. I let's assume there is no ranking effect as well, or there is, but not huge, not 0.1 to 0.9 to 0.5. You know what? I don't want to have ranking effect entered yet, and don't mix it with featureization. Let's understand one step at a time, and then we can merge them. And so we have P 0.7 and Q 0. M is 2, right? Who decides M? Yeah, where did I choose M? Oh, M in the main function. Well, we say no ranking effect involved, but to be true, when we estimate, we have cascade model, which is based on a ranking. So ranking is involved because of the assumptions of the model. Shut it up. So it is not that there is no ranking effect, but it is isolating the effect of ranking only involved from cascade assumption. Yeah, it was on low. Why did you suddenly start roaring? Roaring. Let's see. Alright, I mean, send me 5 text messages. If it was 1, I could. Alright. So, okay. Estimated user type distribution. P is very close, 0.3, 0.69. Estimated exit probabilities, look at them, 0.02. Which are, we generated the data is 0. 0.02, 0.04. 1 for they're very small, and then last one is a bit larger than others, 0.045. It is because of oh, actually it's not the last one, but second to the last. Estimated user intent, I mean third to the last, which is a strange. So estimated user intents, A, intents. So it gave me 2 vectors, nothing obvious from it. Estimated item centroids, X, 2 numbers. I say the second one in the two. No, they are not even matching. I mean, each element size-wise are close, but they have different signs. First one, they are not even matching size-wise. Ground truth for comparison. True user intent. Let's also match true user intent and centroids. Alright, so one thing is that in the estimation section, we are not adding the assumption that the centroids of items and intents are the same. So we are having different ones. Here in the generation section, we have them equal to each other, obviously. So let's through the compute the R matrix, the true R matrix based on the generated parameters. I hope they are, I expect they are quite mutually disjoint, the two R vectors. Oh, we should print it later. Alright. True R matrix, we have two vectors of size 10. So first one is 0.6, the other one is 0.0, 0.56, yes, 0.0. They are quite separate, I can say that. Yeah, but there is no, for example, difference like 0.9. The difference is more like 0.4, 0.5. Yeah, they are disjoint. Pretty good. Yeah. And for estimated R matrix, let's see how close they are. My headache. So first vector. First one with the second one, maybe. Sounds good. Sounds good. Yeah, actually, that's not bad. Good. Not bad. I mean, it's not very off, but I mean, we don't have huge differences as well, so acceptable. Close and close. Alright, and then yeah, we didn't like even in the generating like the true R that was the generating parameters. We don't have a biggest score like 0.9. Maybe we need to change the temperature or shift up the sigmoid to get that. So we want to have a smaller temperature, I guess. So now estimated R matrix. Second vectors with the first one matches. Good. Alright, yeah. So let's make the temperature smaller and see how it goes. saw why it's not 0.1. That would be better. Dude, elbow. I think we first. So if you arrive too late, not too late, then it will be fine. But get back to LA quickly. I call him tonight. So again 0.3, 0.7 almost all the estimated exit probabilities. Ooh, this time much bigger. I mean 0.06. Strange, by the way, it doesn't match the intuition. Intense estimated centroids. When we are estimating centroids and items, do we assume that we know sigma? So AX do we know them? So U is in click position, likelihood of U. That is not about sigma X and sigma. I see. So we say type is the base or centroid. We have centroid, and what users usually are is just a noisy version of that type. So alright, we are still allowing in the estimation section the base for the the centroids for the items and user user feature is separate. User type is separate. Estimated user, these 5 by the way, so estimated item centroids. Well, it is nice if they are close to each other. They are not. They're not. I mean, size, even sign wise, they are not. If we generate it by same A and X in the estimation section with losing the assumption that A and X are equal, it is nice that we end up getting the same, but it is not the case here. And if, well, I think true user intent and estimated user intent comparison of them doesn't make sense because we can have a rotation, so. But comparing ours makes sense. So let's go through our matrix. Let's see if we have something that looks like a partitioning of 1 to n. 0.6 or 0.7, the other one is 0. 0.6, the other one is 0 exact. I mean, I think decreasing the temperature really helped to make them even more separate. Our zeros are working well, still we don't get like 0.8, 0.9, but we have 0.7, 0.8, 0.7, 0.6 relevance, which is good. This one is 0.2, this is not good, 0.3 is not good. We have 0.8 is great, 0.8, 0.7. Okay, I didn't check. But the thing is that all other ones are small. Okay, no, not all of them. Fantastic, good. Yeah, so we switch. That's good. Yes, I like it. And then are they separate? Okay, now how close they are to the estimated R matrix. I guess first one and the second one. 0.5, we are getting 0.7, 0.5, all of them are 0.5, it's annoying. So we don't have as much. So when we compute the R, well, part of it is because we are assuming A and X. Let's fix this part. Mm, okay, okay. I wanted to give the code to ChatGPT. I zone out, I zone out. So we don't use Sigma X Sigma. Perfect. Exactly as I was expecting. We are estimating A base and X base directly, not modeling the noise used in the simulation, which is good. I like it. Or no, they are not used, which is good. In simulation is good. Yes, in during optimization, your model assumes each user type has a fixed alpha vector and as I expected. Yeah, we need a hierarchical model to find sigma x, sigma alpha. Let's not get into that. Plus, I think we are getting using a hierarchical model that uh, estimates m in other task we want. So we will get to know hierarchical models, not for this part. Let's not complicate things. the unpack params. So let's do this. Why we have overflow? Like when we use featureization, even estimated exit probabilities. Well, what are the Q? Okay, Q0. So item centroids and user intents estimated are equal. And then good. And then they are not true and estimated are not equal because we have room for not being equal. I'm fine with that. So true R matrix 0.7, 0.6, 0.5, 0.2, 0.3, 0, 0, 0, and okay. We don't have enough items. Like when we make featureization, we have less control on R. I mean, I guess we have enough control. We just need to, like we are using orthogonal A and or simplex method, but it doesn't give us enough control on the elements of R. So, and what it means to have a, yeah, by the way, can we just shift the definition of having types from R to feature space? That's also something. I think I don't want to take it further from here because I think we need to just have a talk about it. Otherwise, it becomes mental masturbation. All right. 2, 0.3, 0.7, 0, good, 0, good. And the other one, 0, 0, 0, good. And then we have 0, we have something, 0.4, which is good. 0.8, good. 0 is good. 0.65. Oh, that's actually strange. No, actually very good. 0.7 and good. Alright, and estimated R matrix. How close are we? 0.67, yes, 0.5. Why are they so strange? It is like fixed suddenly. No, not good, not good. So we have a lot of 0.55 and a lot of 0.65, or like almost 0.7. How come it happened to be like that? So strange. Like, why are these numbers so equal? I wanna find oh, okay, we have AX actually estimates. So why is it so strange? Yes, flatness. Good enough coarse clusters. Alright, I think I'm good. I just wanna add two of these examples to my overleaf. That will be it. I won't be going further on this, and then yeah.